realistic objects.
Cool. Can everybody see this and hear me okay? Great. Thank you very much for this opportunity. I'm a first-year graduate student at Dartmouth, and I'm excited to talk about the work I did with Team Brady and my PhD advisor, Viola Stoermer. All right, so visual working memory is often studied with simple features like orientations or colors, and we all know that it has a very limited capacity, meaning that you can only remember so much information at once. And this capacity is even thought of as fixed when you are asked to remember more and more information at once. People are consistently pretty bad at the task. But previous studies have consistently also shown that using more meaningful items can actually boost visual working memory performance. For example, this study by Brady and Stoermer compared visual working memory of either real-world objects like this toilet paper, I think it's a basket and whatnot, and compared the performance with just simple features like different colors. Turns out when asked people which stimulus they saw with a 2AFC, people were able to remember real-world objects better than the colors. And another study by Stoermer and Brady, they used Moony face stimuli that are sometimes seen as real face and sometimes not. When participants recognized the Moony face as a real human face, they were able to remember it better compared to when they did not see it as a face, but just random black and white patches. However, all these studies directly ask participants to remember the whole meaningful stimuli themselves, such as which one of these two objects did you see, or do you remember seeing this face? And this leaves it unclear whether the features of these objects are also remembered better. So the question we're asking here is, will more meaningful stimuli also boost memory for other features of the stimuli that are not meaningful themselves, such as the orientation or the colors of the stimulus? For instance, imagine seeing these two different scenarios. In scenario one, you see this cute little car and a cute little ship. In scenario two, you see these random blobby looking things that are very different from each other, but you don't really recognize them. And in a moment, I ask you in scenario one, did you see this car or not? Versus in scenario two, did you see this random blobby thing? You'll find yourself much easier answering whether you saw the car or not compared to the blobby thing in scenario two. And this is because a car is more meaningful to you. They are much more familiar. You have more long-term memory of cars. You have more priors of different kinds of cars and whatnot. But then imagine I asked you instead, did you see a yellow stimulus or a blue stimulus? Notice that whether you saw the colors in scenario one or scenario two, it's the exact same blue versus yellow. It's not necessarily like the color blue is more meaningful to you than color yellow, or compared to any other colors for that matter. But will the fact that you saw the color blue in different scenarios matter? In other words, can memory for simple features like colors also be enhanced if these features are part of a real-world object? More specifically, can these meaningful stimuli effectively serve as a good memory hook and help maintain the feature information as well? In order to investigate this question, we first generated a number of real-world objects in various different colors, like this kettle, a balloon animal, there is xylophone, a jacket, and much more. And as a controlled stimuli, we then morphed and scrambled these objects around so that they are not recognizable anymore. So these four bottom objects right there are the exact same ones as the top ones, but they are morphed around so that you cannot really recognize it. So you can tell that if you just see the bottom four objects, you can't really tell what they are. And the reason why we use this morphed stimuli as a control stimuli is really to match and control for any lower level feature information in real objects, right? So in contrary to simple color squares or dots, real objects are much more visually complex and also have dynamic set of colors in each pixel. So if you look closely to that one kettle on the top left, for example, you can see that each pixel has a little bit of different colors in there. So by scrambling the same exact objects, we can preserve all those visual complexities and various color dynamics within the stimulus while selectively getting rid of the recognizability. Again, what we are asking here is if you saw the colors in these real world objects on the top, will you remember the colors better than seeing them in these weird shapes on the bottom? Okay, so in experiment one, we used a sequential paradigm to test this question. In each trial, 4 objects, either 4 real objects or 4 scrambled objects, were sequentially presented in the center for 300 milliseconds with a 200 millisecond inner stimuli interval. And there was a 1,000 millisecond delay, and participants were asked with a 2 alternative force choice of colors with a 180-degree foil. So here is a quick demo of the experiment. So you can see the first, second, third, and fourth object come out in the center, and then we ask which color did you see? So as you can see here, we never ask anything about what kind of object they saw or whether they saw a real object or a scrambled object. The only thing we ask throughout the entire experiment is what color do you see, left one or the right one? So only color is the relevant information throughout the whole experiment. All right, and before I move on with the data, I just wanted to quickly mention that all the experiments were pre-registered and participants were recruited online. And for data analysis, we computed D prime value as a measure of memory strengths and excluded any participants who had lower than 0.5 overall D prime. And looking at the data, you can see that real world object resulted in better color memory compared to the scrambled object. So far, our data shows that meaningful stimuli can indeed boost simple feature memory as well, and that objects may serve as a good maintenance or retrieval cues that people can rely on in this sequential presentation. But of course, in experiment one, participants somewhat had to rely on the objects as a retrieval cue since they didn't really have much other cues in a sequential paradigm. And recognizable shapes are probably just much easier to tell apart than the scrambled versions. On the contrary, in other visual working paradigms, it's very common to give participants spatial information to retrieve the memory item, like a spatial cue to retrieve the item. So what if we give more spatial information as well in this paradigm? Well, giving more spatial information that participants can rely on, get rid of this realistic object boost. And to test this out in experiment 2, we changed the paradigm to simultaneous display. Here, any 4 of the real world objects or 4 scrambled objects showed up all at the same time in different locations around the center. Again, there was a 1,000 millisecond delay, and we asked the participant with the same exact 2AFC color response with a 180-degree foil. In experiment 2A, there was no spatial cue, and in experiment 2B, there was a spatial cue telling people where the target stimulus was presented. So in experiment 2B, there is really no need for the participants to remember what kind of stimulus it was. They can just focus on answering what color was presented at which location to complete the entire task. Again, this is a quick demo of the experiment 2A without the cue. So you can see all 4 objects show up at the same time. And then we ask them, which color did you see? And then experiment 2B, it's the same thing with a spatial cue, telling them where the object was or where the stimulus was. Again, the only relevant feature here is the color. And other than this display difference, all data collection and analysis, everything were identical to the experiment 1. All right, so the data. In experiment 2A, we see the same exact pattern of data where color memory was better in real world object condition. In experiment 2B, also, we see the exact same data pattern. So people were able to remember colors better when they saw it in real world objects, even though they were given clear spatial information that they could rely on to remember the colors. Now, one question one might have is, isn't this just perceptual difference? Maybe it's just harder to see colors in scrambled objects in general compared to the real world objects. And this is not super likely since we're using 180-degree foils in 2AFC. So you can see on the right side, this is a 180-degree difference on the color wheel that we're using. And it's very clear that the stimulus on the left side is very different than the stimulus on the right, whether they are in the real world object or scrambled object, as long as you have normal color vision and everything. But it is still true that lower level feature arrangements are quite different between the scrambled and the real objects. And we can simply test this out by replacing the scrambled objects with upside down objects, which are harder to recognize, but still have the more well-matched lower level arrangements, just upside down this time. So in experiment 3, we had the exact same simultaneous paradigm as the experiment 2, but just replaced the scrambled object with the upside down object. Other than that, all the data collection analysis, all identical. And for experiment 3, the exact same pattern of data showed where the color memory was better for upright object compared to the upside down object. So in conclusion, our data show that more meaningful stimuli can boost simple feature memory as well. And this is true even when you're given clear spatial information through spatial cues. Also, this is not simply due to perceptual differences between the scrambled versus real world objects, as we were able to replicate the same exact pattern of data with upside down objects. And more broadly, this shows that even though these two feature dimensions, so one is the objectness, whether you can recognize the object or not, the other is color, different colors that we showed, even though these two feature dimensions seem separate and unrelated to each other, they can in fact interact with each other in visual working memory. And this is consistent with the idea of hierarchical memory representations in a way that knowledge or familiarity of the objects can help you maintain the lower level features of those stimuli as well. In other words, meaningfulness of objects may work as a good memory hook so that you can also remember the colors of them better. And overall, it shows that visual working memory capacity for simple features is not completely fixed. Contextual information, like whether the stimuli are meaningful or not, can in fact boost visual working memory performance for even the simple features. So when only using the color dots or squares as visual working memory stimuli, it might not necessarily capture the full story of how we can recruit more capacity depending on the contextual information. Thank you very much, and I'll be happy to answer some questions and discussions. Thank you.
Excellent. That was a great talk. All right, so I think we have, oh man, a lot of questions here. Oh boy.